Alright, so let's talk about how you would do a TLC, and I'm going to kind of cheat and do this from behind the camera so you can kind of see how it works. I tried this before and it didn't really work that well because basically it's just not a wide shot. So in each of these beakers I put in the compounds of interest. So I have my unknown here. This could be one of these three compounds. This is acetanilide, this is paranitroaniline, and this is this is 1,4,2,4-dinitroaniline. So what I'm going to do is I'm going to add, assuming I can get it to come out, roughly 5 mLs of acetone to each of these beakers. Now you should actually weigh it out, measure it out, but in the interest of time, and also I've kind of done this a lot, I'm going to add a little bit in there. Basically we're doing enough just to kind of get it into solution. Next step is I'm going to plate each of them. So I've written across the top of the plate, I've got my product, my acetanilide, my paranitroaniline, and then my dinitroaniline. And to each of these, I'm just going to add a little spot. So let's see if I can get it to where you can see it. Probably saying to yourself, that's not a lot you're adding on there. You shouldn't really be adding that much to these plates. It would surprise you how far a little bit will go. Now I'm going to give it just a minute. And then I'm going to hit it with the UV lamp. With the UV lamp, you can see that I've got 4 spots. So my product on the left, my acetanilide, my paranitroaniline, and my 2,4-dinitroaniline. So I've got my 4 plates ready to go. Now I'm going to take it and I'm going to put it into my developing chamber here. So this is a 1:9 ratio of hexanes to ethyl acetate. This is an optimized mixture. And drop that in there, cover it up, let it get going there, and we'll take a look at it when it's done. All right. So our TLC plate has run to the finish line. What I'm going to do is I'm going to take it out and I'm going to let it dry. And while I'm here, I'm going to dispose of it. Now what we need to do is we need to give it just a few minutes to let the solvent come off. And what's going to follow here is that we're going to use a UV lamp to identify if there's any spots on the plate associated with one of our compounds, and then we're going to hit it with the iodine. So the magic of editing, I'm going to make it look like it's suddenly dried very fast. Alright, so my plate is dried, and what I'm going to do is I'm going to pick it up and let you see it. And if we take down my lamp, we're going to see there are 4 spots. Now it may be a little hard to see on this camera, but actually the spots on the right are different colors. So the one on the right is more of a pink color, the second from the right is more of a gray color, and the one on the left is a gray color. So I'm going to kind of disappear off screen for just a minute, highlight these circles. Now, practically what we can say from this plate is that the final product definitely doesn't contain acetanilide because it's a different retention factor. But as far as paranitroaniline and dinitro 1,2,4-dinitroaniline, we can't really resolve between the two. So because we can't make that resolution, we can't definitively say that we don't have that dinitro or the DNPA in our compound. So what I'm going to do next is I'm going to expose it to some iodine. Now there's a good reason to think the iodine is going to work here. And the reason why I say there's a good reason to believe it will, if we have any type of double bonds or we have an aromatic group, we're likely to have a situation where the iodine will actually react with our given compound. So I'm going to give that just a few minutes to react, and we'll come back and we'll take a look at it. Alright, so my compound has had time to react, and what I'm going to do, and this is something I had to learn through experience, it's been a long time since I've done this, is you want to take your plate out, and it's going to look dark all across. You want to give it just a few minutes to outgas any iodine fumes that are just kind of stuck to the plate itself, that aren't actually part of your analysis. So we'll give that a few minutes, and I'll zoom it down so you can see it. So I give my plates a few minutes to outgas, and if I take a look at it, kind of in the same place I was before. So I definitely have dark spots here for my product, my PNA and my DNPA, but I don't have any spot here for my acetanilide. So the only thing I can really conclude off of this paint is that my product definitely doesn't contain acetanilide. It may contain PNA and DNPA, the dinitroaniline, but other than that, that's all I can really say.